Let's continue with our discussion of the vector potential from a current carrying loop. We arrived at the equations I've written down here in our previous segment, and we have an approximate expression for our mod r minus r prime. Sorry, this should be to the minus 1. And if you look at this, we're going to have, when we substitute this expression into this integral, we're going to get two terms. We're going to get a term due to this 1 here, and that is going to integrate to 0. This is our term at the point of observation, and if you look at it, everything inside the integrand is a constant when I substitute this in. So this term is going to go away, and the only term I have to be concerned with is this second term here, of course multiplied by this expression outside the bracket. So let's then write down that second term only. It's the only one that matters. Okay, so while we're thinking about our bookkeeping, we should really be aware that this phi hat vector that I've written down here, probably we would better label this. We should label it phi hat prime. At this point, it's actually going to be important. You'll remember that it came in as the line element. In other words, it's associated with sources. So we're going to, at this point, label it as phi hat prime, and I didn't do it until now because I didn't want to introduce yet another level of bookkeeping. But if you want to go back through the slides, you could relabel the phi hats everywhere as phi hat primes once you understand why we have to do this. So we're left now with this rather seemingly simple looking integral to do, but we've got this unit vector phi hat prime, which is a function of angle, and we're going to have to think carefully about how to do this. So the way to do it is to convert it to Cartesian so that the basis vectors become independent of angle, and the angular part of those basis vectors is expressed explicitly. So we need to write phi hat prime out in the following way. Okay, so you will have dealt with these expressions like this in the early part of the course, but now you see why it's important for us to label it with a prime. It is the angle phi prime that determines the direction of this vector, which is why I've put the prime here. Okay, the next thing I'm going to do is I'm going to expand this term here, and I'm going to multiply it by this unit vector on this next page. Okay, so here is our expression for the expansion of cos of phi minus phi prime, and here is our expression for the unit vector phi hat prime, and when I multiply this by this, I generate two terms which have a sine squared phi prime, a term which has a sine squared phi prime, a term which has a cos squared phi prime, and then two other terms which are sine phi prime, cos phi prime terms. When we integrate the sine phi prime, cos phi prime terms, those other two, they will go to 0 in the integral under d phi prime. So I haven't even bothered to write them down. All we need to be concerned with now then are the following kinds of integrals. We're going to have our integral then reduces to the following expression. Okay, so we have to do these integrals over the squared angles, and they're both the same. Both of these integrals are pi. Okay, so that's kind of nice because this whole integral becomes, if we look at this, pi times minus sine phi x hat plus pi times cos phi y hat. All right, so let's ask what that vector is. What is that vector? Pi Okay, well that is actually pi times a vector phi hat, which is kind of nice, isn't it? The integral changed the phi hat prime vector to the phi hat vector. Why do I associate this angle, this vector, with the phi hat vector? Because the angles are no longer primed. The primes disappeared in these integrals, and we changed from a phi hat prime as a result of integration to a phi hat up to a factor of pi. So now let's write down our expression for A as we have it to date. Okay, so this is what we have so far. The pi that we generated on the previous page, I've cancelled the 4 pi down here. We have a factor of r squared plus z squared to the 3 halves. If you take a look back, you'll see that this factor comes in outside the integral. I now have a phi hat, and I know A in a small region around our point of interest. Okay, so the next job in the next few slides is going to be to calculate the curl of A. So we want B at R by taking the curl of A and evaluating at our point of observation. So that is what is coming up next.